All right, going into lesson 5 of our current unit for chapters 8 and 10. So this is where chapter 10 begins, is right here with lesson 5. So mostly chapter 10 is going to be dealing with exponential functions. So today we're going to talk about graphing these guys. Here's the general format that you can expect to see for exponential type graphs. We do get to have the advantage of using a calculator for these things because that's always allowed on the IB test, so I allow it as well. So here we go. So with our general format, one thing to get out of this is the C value that you see here is something that's going to create a horizontal asymptote for us. And so that's what you're seeing right here within the notes. And you'll see that on every graph. There's going to be somewhere a horizontal asymptote or boundary line. So here we go. If we wanted to graph something like y equals 2 to the x power. So let me jump over to our calculator here for this. So if I did 2 raised to the x power for this exponential graph and hit graph, you can see right here you're going to get these growth or decay type of curves that can go with these. And so this is a pretty basic form on this. One thing that you're going to notice is as this graph heads towards the left, or you could say as x approaches negative infinity, what happens to your graph? So it looks like it's laying right on top of the x-axis. It's not. It's actually just getting closer and closer and closer to the x-axis, but it would never actually touch it. It's just forever getting closer to it. As you sub in smaller values for x, so as x gets really, really tiny, so let's just say you sub in a value for x like negative 1,000. Right, a really small value for x, you're still not going to get 0 as your answer. You just get a really, really, really small answer. So it gets closer to 0, the smaller x becomes, but it never actually lands on 0. So because of that, y equaling 0, this line right here, is our horizontal asymptote or boundary line. Because that's the line that we are approaching, but we never actually get there. So, and if you think about it too, find some number for x where if you plug it in for x, you get 0 as an answer. You can't. Not to mention, there is no number that you could plug in for x that would get you anything smaller than 0 either. You could never get a negative result from this equation, no matter what you plug in for x. Now, oftentimes students immediately say, well, what if I plug in a 0 for x? Well, what if you plug in a 0 for x? What is 2 to the 0 power? It's not 0, right? It's 1. Anything to the 0 power is 1. And so that actually shows you a point on our graph right here is the point 0, 1 is a point on our graph. If I plug in a negative for x, remember, that does not give you a negative solution. Negative exponents just give you really small solutions. There, it's a negative exponent just gives you a reciprocal scenario right here. So if I plug in a negative 1, that makes this 1 over 2. So it just gives you a reciprocal function. So in fact, if I have negative 1 for x, the result is 1/2 right there. So can't get a 0, can't get a negative, so that's why you're seeing this graph get closer to 0, but it's never going to touch it or cross it. And so as far as creating our own graph, I do want you to use your calculator to get some accuracy for some points. We've already identified a couple. 0, 1 is a point. Negative 1, 1/2 is a point. But where could I get some other points? You could plug in point numbers by hand. There's nothing wrong with that. I could plug in a 1. Let me start by just plotting some points that we already know. So 0, 1, negative 1, and 0.5. What if you plugged in a 1 for x? What would that give you? What's 2 to the first power? What if you plug in a 2 for x? So 2 to the second power. And so you could certainly plug in some numbers by hand to get these points. Where else could you look? You can look at the table of your calculator. And so if you hit second table, I can get every number under the sun for this graph. And so I can easily pick some relative points that I see on my table and just plot those on my graph. right? Don't get too extreme here. We're not going to start getting into these gigantic numbers or extremely tiny numbers, right? Those are fairly irrelevant on the graph. We want to plot the main numbers that we can visibly notice a difference on. So these areas right here are going to be the ones that we would want to plot, just for accuracy's sake. So we're going to do this. One thing you got to make sure as you draw this curve that you do not touch or cross your boundary line, your asymptote. So you're going to get closer to it, but always make sure that you do not touch that line. And so oftentimes what I'll have students do is draw that line as a marker for yourself so that you make sure that you don't cross it. That's a boundary line that you're not allowed to cross. As we get into a couple other graphs here, again, you can continue to take advantage of your calculator, so this gets really simple to do. But let me just identify a couple things by hand on this next graph. Right here, the +2, that's our C value, and it's the C value that creates the asymptote. So this guy, instead of being at 0, has now been shifted up 2 units, which means your boundary line has been shifted up 2 units. So for this one, I'm going to get a boundary line right here that I cannot cross. And so that's the horizontal asymptote for this graph. But again, I could continue to use my calculator, or if I really wanted to, I could plug in some points by hand. But most students, and I would confess I wouldn't do that either because it's too simple to just do my calculator. And since we're allowed to do that by IB standards, take advantage of that. So I'm going to go 3 raised to the negative x power plus 2. So right off the bat, you can see there's a boundary line right here at y = 2 that my graph will never actually touch. Even though it gets really close to it, it doesn't actually touch it. And so one of the things you'll also notice about that is the negative created a reflection across the y-axis. So the negative x created the reflection across the y-axis. So now you're getting this look instead of the one that we just had, which was doing this, right, where the numbers were increasing. Now over time the numbers are decreasing because of the negative x. So we get that look here, and again, if I just go to my table, I can grab some relevant points off of this. Maybe -1.5 would be a good one. 0, 3, 1, and 2.3. Those would be very relevant points that I could plot on my grid and sketch my graph. So plot those points so that your graph is accurate. Then go on with the sketch of your graph for what it should look like. I'm just doing a quick sketch right now for the sake of notes and getting through the video for you, but plot points on your graph so you get accuracy on your graph. Right here, so what happens when we make the base negative in a case like this? So I just wanted to give you another look. Well, one thing you want you to notice right off the bat is the asymptote, or the boundary line. So there is no plus or minus anything over here, so that automatically I know my boundary line is at 0. And that's something I would encourage you to identify right off the bat, because that's a line that you cannot cross when you make your graph. But what happens when you create a negative base? So -2 raised to the x power. There you go. Now it reflects across the x-axis. So now it's reflecting downward. So now my graph is below the x-axis and below the boundary line. So for this case right here, again, I'm going to go to the table and actually plot some accurate points. But just for the sake of notes right now, I'm going to give you a quick sketch. But again, you're going to shoot for some accuracy by making use of your table when you do graphs like this. All right, last one for this video. We have a piecewise function. We did piecewise functions in chapter 8, so here's a connection between chapters 8 and chapters 10, is we're now doing a piecewise function with exponential graphs. Let me start with the easier function of the two. So this one that you see right here, one thing I encouraged in the notes for piecewise functions back in chapter 8 was to do them in pencil first, and then you might need to erase whatever doesn't fit within the domain that you're given here. So I'm going to do these guys first in pencil, then I'll color them just so we can always see the difference between the two graphs. So this right here is a linear function, so starts at -1, and then I have a slope of 1/1. So let me start at -1, and then use my slope of up 1/1 to plot a few more points. And so technically, this would be the entire graph. But remember, with a piecewise function, we have to take into account the domain that I'm given here. So this graph is limited to only x's that are less than -1. Or you could say x's that are to the left of -1. So for this case, here's where my graph hit -1 right here. And because it said less than, I can only graph that portion of the graph. And so that's all I'm allowed to show. Remember that this is an open circle because there's no equal sign on him. So I'm going to graph this one as an open circle. And there we go. So that's all you're allowed to show for that graph. Remember that these are always connected. So where one begins, the other one ends. And so if this graph is headed off to the left at -1, this graph is going to head off to the right at -1. They won't overlap. So where one ends, the other will begin for us. In this case here, again, here's the new graph. I have 1/2 raised to the x power. And again, I definitely want to take advantage of my table for some accurate points on this graph. And so if I did my 1/2, and you know what, let me put parentheses around that. So 1/2, parentheses raised to the x power, and hit graph. So here's the function, and now I just need to make sure I get some accurate points. So based on this, I'm going to start with -1 and then use numbers that are greater than -1. So if I go to my table, I'm going to start with -1. So -1, 2 is going to be the first point that I plot, and then I want to go greater than -1. So 0, 1, 1.5, so on and so on. And so those are the numbers I'm going to use now to make my graph based on this domain. So -1, 2 would be the first one that I would plot. He has an equal sign, so I am going to fill this one in and plot my next couple points here. So 0, 1, 1.5, and I'll throw one more in there, 2 1/4. And then, as always, make sure you don't cross your boundary line. So this graph is going to do this. And so we're now kind of combining some old with new. So that was our red graph, and this was our blue graph. And so those are the two graphs. But again, one thing I'm always checking for on my test is make sure that where one ends, the other one begins. There's no overlap here, so this one is filled in because it does include -1, but this one is open because it does not include -1. One really common mistake I get on this chapter test is for this statement that says this. Where you see x is less than -1, immediately a student will say, okay, well, less than -1, so -2 is the first point that I would plot. Remember, that's not true. Less than -1 means -1.00000001. It's everything that leads up to -1. It just doesn't include -1. And so make sure that that gets properly represented within your graph.